I've pretty much changed my focus to the question, why is a plant healthy? Because if you think about yourself, most of the times we are exposed to super spreaders, and and most of us stay healthy. So the big question is, why are we healthy? Not why are we sick? Because those guys are everywhere, anytime, and we found out that when we look at peas in the field and they look perfectly healthy, they still have the same pathogens inside, and the sick peas. And I find it much more interesting to turn around the question. And because it also opens the view to what Philippe at the beginning said, to the real systems view. And you will see a lot of reminiscences to what we saw yesterday, the day before, in the way I build up my stuff. Somebody got out of my presentation. Okay, I want to talk about challenges that are common to conventional and organic agriculture, and requirements for the future, and how biodiversity helps to achieve these requirements. This is in a nutshell sort of the topics. So if you look at the challenges, of course, we have the biodiversity catastrophe and we have global heating that are connected. We have an energy crisis, we have war and insecurity, and we need to use less pesticides and fertilizers in the future, because 1 kilo of mineral nitrogen means 1 kilo of fossil fuel. And that hasn't changed in the last 60 years. Haber-Bosch takes as much energy no matter what you do. The question is, do we need more and more ecological set-aside in order to keep the world running? My opinion is we need more ecology inside our fields. Of course, we have increases in fertilizers and energy. We have to ask, where does the seed come from? Germany is importing most of its maize seed from the Ukraine and could not live without the seed from the Ukraine. How idiotic can you be? Are we producing feed or are we producing food? And giving as feed what we can't eat. That would be the difference. So the challenges are pretty much the same to conventional agriculture and to organic agriculture, except that conventional have to deal with less fertilizers and less pesticides, and that means plant health is a challenge. Organics have to deal with too low productivity. We still have to get better at that. That's no question. And we also have plant health as a challenge. So many common and a few problems are system specific. So my hypothesis, in the future, the common problems will increase. So that's why I don't care so much talking organic versus conventional. I find working for the organic world, I'm providing solutions for the conventionals just as well, because they have to reduce the pesticides. So if you think about ecological processes and agricultural systems, a lot of people think, oh yes, organic is the solution. But if we look closely, yes, we have high fossil fuel inputs in conventional, we have soil degradation, we have water mining, contamination, we have biodiversity. And organics, they have also a lot of fossil fuel inputs, maybe a little less, maybe. Because if you count the mineral fertilizers, that saves energy. Yeah, less soil degradation, and I mean, applying one field with glyphosate, you can run twice a harrow across it, because the production of glyphosate is extremely energy intensive. So the energy hidden in the pesticides is tremendous. Maybe a little bit less soil degradation. But it depends, because a lot of organics are not productive enough and they may mine for organic matter. Water mining is happening. If you look to the organics in Spain and North Africa, we are importing water from places where we shouldn't import water from. And maybe a little bit less biodiversity loss. If you really want to do ecological, but all depend on ecological cycles. Even if you have inputs, the ecological cycles are the basis. And ecology-based systems should actually run on no fossil fuel inputs. It's a very interesting idea and a difficult one. There should be no soil degradation, and water mining and contamination should not happen, and biodiversity should not be lost. That's already bad enough, but we already have climate change. We already have lost a lot of soils. We already have lost a lot of water and contaminated much of it. And biodiversity is already lost at a very fast pace. Some of the stuff we can maybe mitigate. We may get better water and may be able to build up soils a little bit, but we cannot really bring back what has been lost, unfortunately. And this is why I consider biodiversity loss one of the most urgent factors. So we need to buffer climate stress. We need to buffer harmless organisms. We need to reduce inputs. We need to produce good yields. We have to improve ecosystem services. And we have to provide additional products, which means renewable energy, non-food, and all these things that we are currently getting out of fossil resources. And we basically have to work on doing all this together. And all this can be provided by biodiversity. And this is what I'm going to talk about in a bit. Biodiversity is the variability among living organisms from all sources, inter alia, terrestrial, marine, other aquatic ecosystems and ecological complexes, of which they are part. This includes within species, between species, and of ecosystems. So what belongs to biodiversity? Which organisms?
Every organism.
Yeah, but name them.
Man, microorganisms, fungi, bacteria.
Oh, you're already very good, because most people think plants, animals, and maybe ecosystems. And you already named what most people don't think about. And it's the microorganisms. The highest diversity we have, of course, in the microorganisms, because they are the oldest. And we know so little about them. The Anthropocene has created in the past 30, 40 years a lot of new insights, and the COVID epidemic has made a few people sit down and write some very nice papers. This is why from 20 to 22, there's a few really good review papers giving new insights. So Sariola and Gilbert wrote about the public symbiotic perspective on public health, the ambivalence of microbes in the Anthropocene. And what they write there, that we are no individuals. Yeah? We are holobionts. We inherit about 22,000 genes from our parents and 8 million from the microbiome. So who is the boss? Are we just vehicles for the microorganisms? Is this why we are exploding in humans and the microorganisms making a big mistake? We have too many humans in this world? I don't know. It depends on the perspective. 90 to 99% of all cells that are standing in front of you are microorganisms. It's just that human cells are so big that I look like a human. That's about it. But the rest is the guys inside me and on my skin. So dysbiosis is a new, very important idea of what can cause disease. Yeah? Deficient or aberrant microbiomes. I mean, and most of what, when we don't feel very good, stomach is weird or so, it's nothing else but a dysbiosis, because somebody isn't capable of taking care of whatever wrong stuff we have put into our body. Yeah? But they are recognized more and more as reasons for diseases and even mental problems. I did give you a list of references I sent to you by mail, and I also put the link to a talk about glyphosate, where I also talk a lot about dysbiosis. But it also applies to plants, animals, and soils. Yeah? And this is why we also talk about One Health. A soil that is treated like that, where the water is standing because there's too much compaction, is not a healthy soil. If you think about plants and microorganisms, we should never forget who is doing the job. Plants are fixing CO2 and they're giving the seed to the ground, and a lot of it. And it's a little bit like in a bar. The plant supplies the seed and also water sometimes, and there are bacteria and fungi, and they pay with nitrogen, micronutrients, phosphorus, and sometimes also with water. So we have, of course, rhizobia, we have soil, the soil teeming with microorganisms. And if you pull the plant out of the ground and it looks like that, and the soil glues to the roots, this is because there's mucus exuded by the plant, keeping the roots covered with the soil, which is teeming with microorganisms. This is called the rhizosphere, the rhizosheath. And this is full of the guys that the plants need. And the plants attract organisms that they need as much as possible. And if a plant is covered, and if a root is covered with this, root pathogens have much less of a chance to enter. This is a little bit like making bread. You take flour, you take sourdough or yeast, and you make bread. And if the bread is good, it has a good structure. It doesn't have big holes and small holes. It has quite uniform structure. It has some solidity, but it's soft. Yeah. But, and this is a COVID picture, because at some point my husband took the dry yeast and it was too old, and he tried to make bread, and that's what came out. A compacted bread that you could eat. It was really disgusting. So the microorganisms didn't work. And this is also part of what happens in our soils if we don't treat them well. So this bread is a little bit like the soil after a maize harvest late in fall, when there's a lot of compaction in the soil. And this is what it looks inside. Yeah? You have a compacted soil, you have lessivation, you have not much roots. But if you have such a bread, then the stuff may grow on top. And this is what the soil looks like. Yeah, you have roots, you have structure, you have a lot of activity. And this is what we need. So about 30% of the assimilates coming in from photosynthesis are deposited into the soil. And if this is about 100 to 1,000 cubic meters per hectare of exudates are leaked per year. And this has been looked at already a long time ago. This is a reference from 1976 from the University of Hohenheim. So it's nothing new, but nobody cared. If you apply manure, it's about 15 to 25 tons per hectare. It's just a little bit. Plants are stronger. That doesn't mean we shouldn't apply manure, but we shouldn't forget about the plants. And this is why the EU greening, pushing farmers to keep the fields green in the winter is so important. And the warmer it gets in the winter, the more important it is to have plants, because any activity of the plant will add organic matter to the ground and help the soil. And this is what we have to teach the farmers, that it's not just costing money, that it's actually doing something. So diversified plant exudates supply the soil with C and diversify and activate soil life. And this is why it makes a difference to have pure stands or mixtures, to have genetically uniform plants or to have genetically diverse populations. And just to give you an idea, what can exudates do? You have here a soil. We started with winter wheat in 1918. It was sown in October 18, and in May 19 looked into the ground, looks halfway decent, and we have developed a soil quality index on 2 levels, so 15 and 30 centimeters, and the sum of the quality index is not very high. The maximum is 50, and 50 would be 100. You don't ever reach that, but if you have 50, you are really good. And already between 30 and 50 is quite useful. Deborah can tell you more about it. She has done most of this data. So here in May 19, very moderate, index 17. Then they harvested the wheat, and then we planted in the field on the 17th of September either we left it bare, we let the weeds grow, or we put in a mixture from a breeder that's supposed to be good for potatoes as a cover crop before. Then we put triticale veg mixture or veg alone. And you can see the difference, what happened within exactly 5 weeks. From 17th September until the 23rd of October when we looked into the soil. And you see the difference depending on what you plant. You can get between 26 and 41, but already much better than what we had in the pure crop of wheat. So this is what plants can do to the soil in a short time. The plant species and the mixture are important factors. So if you plant mustard, it looks good on top, but it doesn't produce much roots. Mustard is about the worst cover crop you could ever use. Total nonsense. Except for producing seed and annoying you in the future. At least take oilseed radish. Yes?
Sorry, maybe I missed it, but what did these numbers mean?
This is a soil structure index that we developed. And for 2 layers, the upper layer 15 centimeters and 30 centimeters, the lower layer. And the max, it is a grade put together out of what you see in terms of structure, in crumbliness, in rooting, and all kinds of, you can ask later Deborah on the details, but the maximum you can get per layer is 50. And so the sum of the two can be 100 in theory. Yeah.
And it's not about nutrients or so.
No,
structure.
No, it's just shovelomics.
Right.
Take your spade and check.
Right.
That's what every farmer can actually do easily. And that's what we try also to focus on. Farmers can look at their soil and do it. And you have this initiative everywhere. You have them in Holland, you have them in Scotland. Christine Jones, nothing else she's doing. So microorganisms and pathogens, keep in mind, almost all microorganisms are useful and neutral. Pathogens have a hard time outside their host. They just survive as they are adapted to the life inside their host. So soil inhabitants are superb competitors against pathogens. And so if they are suppressed by chemicals, for example, the soil inhabitants, then the pathogens have a much better life. For pathogens, crops are a resource. The easier accessible the resource, for example, many easily accessible nutrients. We know, everybody who works with aphids knows, if you put a lot of nitrogen fertilizer, you have larger, softer cells. It's easier for the aphids to get to the food they want. The same applies for many pathogens. So if there's a disbalance in nutrition in the plants, usually the pathogens have an advantage. Actually true for us also. So the easier accessible certain resources, the more pathogens. And the lower the microbial biomass and activity in the soil, the higher the survival of the pathogens. Because otherwise, the microbial biomass may simply digest many of the pathogens before they make it to the next crop. Because they are also a food source. So another nice paper coming out in the COVID pandemic was the concept of One Health via microorganisms. And Sid and Hernando Amado, they really showed what does it do in terms of when we think antibiotics. Yeah? And this is why antibiotics are everywhere and they're cycling through the whole. Yeah? And this is why it's relevant that all herbicides are antibiotics and that we are producing antibiotic resistance in our soils. I put a link to a talk about the indirect effects on glyphosate as an example, where you can see how it really enhances antibiotic resistance everywhere. It's not only that we are feeding them to our animals like crazy, but it's also we simply spread them widely on the ground. And so it's worthwhile looking at this picture in more detail, because it's what an individual does has an effect, of course, on my own health, but it also affects the global health with this. Because if I don't pay attention how I take my antibiotics and what I do, I may create antibiotic resistant guys in myself and then put them in the sewage, and here they go into the environment. And then we take the sewage, sorry, Dutch people, we take the Dutch sewage and spread it in Germany from the Dutch animals. 100 million chicken. I don't know how many you have by now, but it's a lot. And of course, that means we are all connected. And so if we look at organic inputs, especially C, what they do to nutrients and microorganisms, we look at the soil chemistry, we look at the soil structure, we look at the soil structure affects the water retention, the oxygen supply, it affects the temperature, nutrient availability, and it all affects the microbial community. Of nutrients is only one of many ways organic amendments affect microorganisms in soils. And if you really read Justus von Liebig, then you learn that Justus von Liebig, in his later life, in the last 25 years of his life, tried to point out to people, I was wrong. Don't just use mineral nitrogen. We have to recycle the manures, because the mineral nitrogen alone will not feed the plants. But nobody wants to listen to him. They went as far as naming a university after him with the wrong information. And the fact is that if we don't recycle the whole stuff, we are having problems. So what can we do in agriculture? We can avoid soil compaction in naked soil because they inhibit water uptake, they hinder plant growth, and they make soil susceptible to erosion. So if you have stuff like that, this is a problem. Here, you see a wheel track, and you see faba beans, and you see where they are not growing. Yeah? Because they can't when it's so compacted. Or you get that. And this is at the end of a maize field in October. I mean, this should simply be illegal. And one way, if you do strip cropping, and then you have your wheat coming out, you can not only sow where the wheat is, you could even use a manure spreader and throw some clover seed under the maize in August. It will start slowly germinating, and as the maize dries up, it already starts greening underneath the maize, and in the moment you harvest the maize, you will have new growth, and you won't have such mess. Yeah? And if you're in a climate like here, you will harvest the maize late. So you have to put something underneath before harvest. So otherwise it stays like this over winter. And we have a lot of erosion. So if we look about the current system, there are some key factors. And those are cascading effects leading to extinctions, and they are due to industrial agriculture. The key factor one is the landscape structure. We have increased field size, it's all machine oriented, we have very few field edges and very few biotops. And the key factor two is N. It triggers additional inputs. Because the fertilizer N makes you independent of N regeneration in the system, and you can tighten the rotations or get rid of rotations. In Germany, we all agreed that it's not to be called rotation anymore, it's just the following of crops. It has nothing to do with planning on health. So you have more tillers per square meter if you look at the cereal with nitrogen. That means you have also more weeds, because the weeds are usually following the nitrogen. That means you need herbicides, because the weeds are N profiteers. You have a more humid microclimate. You need fungicides. You have a more excessive growth. You need insecticides against the aphids and others. Then they grow too well. You have to stabilize them against lodging. Then you use CCC. Then you may have certain fungicides, especially that extend the growing period, and then you have to use seccation in order to be able to harvest. That means you use another herbicide to kill the wheat. Germany, it's illegal, but in many other countries they do that. And then, of course, you have a lot of additional inputs. I was called by an agricultural business guy who was selling agricultural products to the farmers, and he said he was told by the industry you can sell Roundup almost for free, because you will sell so much more fertilizers and pesticides. You will make a lot of money if you make people use Roundup. He told me that in his own words. I was like, So, if you look at what crop heterogeneity means, it means enhancing multi-trophic diversity across agricultural regions. And this is a very nice paper coming out of the Charnke group in Göttingen, but they asked people around the world, I think it's 80 or 90 co-authors, throwing data together. And what do they find? Increasing crop heterogeneity was more beneficial for multi-trophic diversity than increasing semi-natural cover. The effect of decreasing mean field size from 5 to 2.8 hectares was as strong as the effect of increasing semi-natural cover from 0.5 to 11%. So go for strips. It's perfect. Because we can do a lot more for nature, and we can do a lot more for the animals and for whoever else lives out there if we have more diversity also in our agriculture. And don't land sparing or land sharing. I'm quite clear what I think is better. That doesn't mean we don't need nature protection, but it's not that we have to take more and more productive fields out of production. We have to change the way we produce in these fields. And so we can adapt the system. We can have intensive cover crops. They affect the soil physics, the soil biology, the soil chemistry, and the climate also, of course, affects the biology. Yeah. So we have to look at the temperature, humidity, UV protection. We have to look at calcium, organic matter, pH, and all these things, and we have to look at it together. If we reduce tillage, what happens? Usually we increase weed pressure, at least in our conditions, if we do it wrong. But we also increase biological activity in the soil, if we do it well. But we reduce erosion, we improve water availability, we reduce energy use, but we may also reduce soil mineralization. Yeah? And especially in organic agriculture, that's a problem. In conventional, you just add more herbicides and more nitrogen. This is a solution that will not work in the long run. We are doing better, is my opinion, to have some superficial tillage, but also we have to use the correct rotation to reduce the weed pressure. Keep in mind, reducing tillage you can only do if you have a good field. If your field is a mess and you reduce tillage, you create a greater mess. If you have a lot of weed pressure, don't start with it. So what can we do? Cover cropping, compost use, mixed cropping, and mulch could all help against some of these problems. And if we use cover crops instead of fallow, you have seen these pictures before. In the fall, it may look like this, and in the winter and in summer like this, if you do conventional maize growing. What we could do, we could have over winter a cover crop of triticale vetch, for example. We can put it on the ground and do direct sowing. We can mulch it and sow directly into the mulch, the maize. And after 1 week, it may look like this on the ground. After 2 weeks, this. And in the end, it looks like that. Still, we have done quite a bit of experiments on that. And one outcome is what happens if you, instead of just mulching it, you take away the biomass and you do a shallow rototilling, or you rototill the biomass in. Does the maize need the above ground biomass or not? Can we use it for something else? So what you see here is this is a 2-year experiment. Those are the overall yields of the vetch in the 2 years, of the clover that we use as, we had two types of cover crops in the winter, vetch and clover. It was actually Trifolium incarnatum, so crimson clover. Then the maize was the same in both years, mean yield. Then after the maize, we put in peas and wheat, because another thing was, oh God, we have here a legume. What happens if we have wheat pea mixtures? Will the peas react to the legume? And I can tell you, no. And now you look, and we did different type of tillage. We tried the rototill, the versus direct sowing. That means using 5 centimeter tillage versus direct sowing. Rototilling had more than 4 tons more yield in the maize. Mulch versus harvest was basically no difference. That means you can take away the above ground biomass and you still have the same yield in the maize, because it's the below ground stuff that counts. And this is why early versus late makes a difference. If you do early sowing versus late, but statistically it was not significant, but I can make a whole speech about statistical significance and what it means. It's a difference, I see. But wedge was much better than clover. And that had to do, wedge is a better weed suppressor. Wedge makes deeper roots, faster roots. And so winter wedge is an incredibly good cover crop. And especially when you mix it with a little bit of triticale to get some grassy stuff in it. But it also made a lot more yield in the maize. So we save fertilizers. We got almost conventional yields in this system without, it's all in organics we are doing this. Yeah? We didn't need any herbicides, and wedge is a very good weed suppressor. Wedge is highly allelopathic in addition. We protect the soil in the winter and we control erosion. So this is a win-win-win-win situation. Our aqua project, you see the poster here, is a project we started in 2010. So we are now 15 years comparing minimum tillage with a regular plow system. And we are looking at applying regularly compost to the field on an average 5 tons dry matter per hectare a year. However, we don't do it every year. We use the crops that profit most from the compost. And so sometimes after 3 years, we put 15 tons and then we don't put anything for 2 years. Then we apply living and dead mulch depending on the crop and how what is suitable. And for the past 5 years, we have also worked on using these biostimulants that have been promoted a lot by the regenerative movement, compost tea and ferment and so on, to simply see if it makes a difference. And honestly, it doesn't. Not in our conditions. But it can be that with other soils, with other climatic conditions, they do make a difference. But for our soil conditions, where we are in Central Europe and we have relatively good conditions, it's only cost money. We also work on farm. We have now we have only 4 farms left, but because some farmers didn't want to continue, we do NMIN, soil water, infiltration rates. We do soil stability, temperature, humidity in the soil, in the air. We have suction cups taking the leachate from 1 meter depth, and we look at the soil carbon down to 1 meter. We do yield economics and microbiology. There's a little bit on this poster here by Deborah, and we do greenhouse gases. What do we find? After 8 to 13 years, we found that in the top 15 centimeters, we had 53% more sea org after 8 and 9 years when we were tested. That was published in 2020, and we have now the data from 1 meter depth after 10 years, and we can confirm this, and no difference below 15 centimeters. That means we really have more carbon in the ground, because a lot of people always say, yeah, but you get more on top, you get less below. For us, it's not true. This is just impressive. Compost and cover crops maintained weed seed bank. That means, compared to the plow, if we diligently applied compost and used cover crops, we could go on reduced tillage. I don't say no till, and we wouldn't have more weed pressure than in the regularly plowed system. We just had the weed pressure you have in organics. And we are just redoing these tests because those were done after up to 2018, and now we are doing the next 4 years rotation. Soil porosity, air capacity under plow was higher, but the aggregate stability was higher under reduced tillage, and the water uptake capacity was the same. So we did not lose anything about infiltration. We just had a more solid soil, which is normal under reduced tillage, but it did not damage the soil structure badly. And on farm, they started only in 2020 when this got financed. After 3 years, there were already measurable effects within only 3 years. It's just been published. But on the long run, mulch in potatoes, very interesting for health. You have here the big experiment, and you have strips that are plowed. This was in the beginning, we said, it was the farmers that told us to do that. They said, if you want to do reduced tillage in potatoes, put mulch, and you don't have problems with late blight, and you don't have problems with potato beetle. And I said, I want to see that. I have never seen anything work against late blight and potato beetles. And so we said, okay, let's do it. The farmer said. So in the beginning, we had plowed part of the field and the minimum till with mulch. You can see in the color. But what you also see is a lot more brown, less plants here than there. That was a very smart student in 2014, the first time we had potatoes with mulch. And back then it was still expensive to get a drone picture taken. There was only one drone at the whole faculty. And she couldn't find anybody, and she took the risk to pay the €100 out of her own pocket to get this picture taken. Of course, I paid for it. I mean, I was very happy with her. So what we find, on average, in all the experiments we did, independent if we plow or if we use minimum tillage, we reduce the late blight pressure, that means the area under disease, the cumulative disease as area under the curve, by about 1/3 in every single year we look. Climate change is making that we don't have late blight every year, so we cannot look every year. But whenever there is late blight, we do look. So it's not the tillage, it's the mulch. And then we observed the beetles. And I promise this is not Photoshop. This is reality. Yeah? We did not put one plot here and one plot there and then put them next to each other. This is directly neighboring potatoes with and without mulch. And it tells you what the beetles like and don't like. And this is what it looks from the air. That was in 2018. And you can see B is mulch and A is without mulch. And you can see the beetles also go in the mulch, but not as much. And we have now, I put 3 more papers in the list of references I gave you from Christiane Weiler, who did detailed experiments, and she did choice experiments and mark release experiments and looked at in detail, and she could find quite a few interesting things. Among others, when you have mulch and it turns light color after a while, it gets warmer in the above ground canopy. It is hygroscopic. And that means you have lower air humidity. This is, of course, explains the late blight. And it gets warmer because it's easier to warm up the air. And as we had the temperature recorded, we found several periods when it gets hot that the eggs of the potato beetles simply get fried. So the mean temperature doesn't help you. It's enough to have an hour above 38. Then the eggs are fried. Yeah? So it is important when you look at microclimate, not only look at the means, look at the daily and look at the peaks. The mulch also does stuff to the soil. We had in the very hot times, the surface temperature of the soil can get 60 degrees, the naked soil. We have 20 degrees less under the mulch, and 15 centimeters in the ground, we still have 5 degrees difference in soil temperature. That affects the potato quality. That one was published as the beetles arrive later in the mulch, so it's late to the party. And you can see the larvae are reduced tremendously. And another thing, we don't disturb the plants anymore because we have mulch. We don't go in with hilling and all this stuff. And all of a sudden you see the potato roots entering into the mulch, feeding themselves. And that's why don't use straw. Give them something to eat with the mulch. Give them some grass clover or give them better triticale vetch. They can eat this, and that really helps the potatoes. Straw is not good for that reason. If you're a conventional farmer, it doesn't matter because you have given them so much nitrogen in the ground, so it doesn't matter. And then you can use straw to block the leaking. But here, in organic farming, you're better off giving them something to eat. And the farmer said, what gives good milk in the cows is good for mulch in the potatoes. This is what the roots look like in a very hot moment. Then you know who is happy. And that after everything has died off. You don't think there's much, yeah? But this had been mulched, this had not been mulched, and there was a heavy rain in August after the die-off of the, and still we have protection. And this is the temperature below ground in the top 15 centimeters, and you see in the real hot moments up to 4 degrees less. So what's happening here? Now comes the messy picture. We have seen messy pictures before. When I started in Germany 27 years ago, our leftist newspaper had a competition running for the most idiotic graphs. And that means they called it not idiotic, they called it totally chaotic. And I wish I could send that to them, but it's over because this is what ecology does. Look at it. And this is not even all we can do. I just put a few things we could do to change. We could vary the tillage depth, the timing of planting, of tillage, of whatever distance in time. That means rotation. How big is the distance between plants or fields? Microclimate. We can destroy inocular seeds, support natural enemies. There's so many things you can do. And this is what happens. So if I vary the depth in tillage, it will affect the fertility management. It will affect the drainage. It will affect the destruction of inocular seeds. If I look at the drainage, it affects the microclimate. But the microclimate is also affected by the hedges. The microclimate is also affected by fertility, as I said. So if you look at what fertility does, it really affects many of these factors. And this is why N is so important. And of course, all the other fertilizers and the balance in the fertility. So we have published that also, the interactive web, and it's just as messy as all the other stuff you saw yesterday and the day before, what Thomas showed. Or so interesting thing is, when I traveled in Brazil, this was a trader for agricultural inputs. And when you looked inside, he was selling cover crops. Why? Nothing worked against these bloody nematodes anymore. Only the cover crops work. The right plants can suppress nematodes, but the chemicals the nematodes simply love. And then they found out also that the cover crops do a lot of other good. This is, if you can read it, mucuna is a it's some bean. Then this is Cockatiel Caligari. The Caligari was the scientist, and this is just a mixture. And then Nabo forajero is radish, yeah. And then we have Trigo morisco is buckwheat, and Sudan grass, just as some examples. So there's multiple positive interactions that can happen in mixed cropping. So number one is, you have all these guys in the ground, and they interact. They interact for C, because the C is coming in, and they're taking C from the plants. Then you have water, nitrogen, phosphorus. The associated plants and mycorrhiza supply ecological services. And you may even have protection, because the mycorrhiza will cover up your plants. So protection from weeds, harmful insects, and pathogens. And again, the assimilates go into the ground, and they drive the system. Don't forget that. When we look at competition, we have peas alone or peas with oats. in a field that was totally infested with, it's not mustard, it was, I forgot the name, Hederich. It's also a brassica, looks like mustard. Then we have genetically uniform wheat or our wheat population in a farmer's field. It was very impressive. So competitive ability is important, but it's nothing new. In 1767, Tozzetti wrote that wheat-rye mixtures are healthy, and wheat alone was destroyed by rust. And in the 1980s, in the former East Germany, 80% of the fungicides were saved on malting barley by simply using mixtures resistant to cloudy mildew. And in Colombia, they're saving every year more than 100 million in fungicides simply by using, what do you call that, multi-lines of coffee. Because coffee, of course, you have to look for the quality. But the same in the malting barley. Right? They exported all this malt to West Germany. They never complained about the malt. They had good malt from the East. And then came the unification, and the chemical industry came and said, mixtures are communist. Take our pesticides. This is truth. I talked to some of the scientists, and I saw a lot of anger in the East for some reasons. So you can do mixtures against insects. If you grow barley with maize, the wireworms prefer the barley to the maize. So you can protect your maize also because you put the maize deeper down than the barley. And biodiversity and mixing is a method. You have to focus on weeds, insects, and pathogens together. Yeah? That's the system. And natural enemies are supported directly in the field. And so diversity increases yield, but reduces harvest index. I pointed that out. That can happen. So if we talk agroecology, management and diversity, we talk soil fertility, microbial activity, the choice of varieties, the variety diversity, useful rotations, reduced field size, and other preventive methods. And all this means increased diversity, increased diversity, increased diversity, increased diversity. That's what it is. It's like a mantra. So what's the problem? Why is not everybody doing it? And so I have a wonderful postdoc by now, or I would say senior scientist, Odette Whedon, who worked on our wheat populations, and said, yeah, we know it works. I'm sick of it. I want to see that people eat it, because otherwise we do all this work and it has to no avail. So I want to look at, she started looking at wheat mixtures within the value chain. We use heterogeneous populations, wheat pea mixtures, and look what happens. The composite cross is a heterogeneous population made out of multi-cross 20 varieties, selected for good performance in organic agriculture in the 20th century in the UK, which means climatic adaptation may not be exactly ours. And then made 3 populations out of that. 1 population out of the 9 high-yielding parents, 1 out of 12 high baking quality parents, and 1 of the yield by quality cross. And if you're careful, you can see this is 9, this is 12, and this is 9 by 11 because Bessel-Steyr is both. It's high yielding and high quality. This is why it adds up to 21, if you wish. So we registered in the new, under the new EU rules, the population, the yield by quality mix in the F15 or 16, and call it E-quality. That's the name of the variety, and it's open source seed, which means it is, everybody can use it for breeding. But they are not allowed to put any protection on it. So we have variability for height, resistance, architecture, color, arms, but they are similar for maturity, management, and the question was the quality, of course, because it's a yield by quality mix. And we found out it's quite good, actually. So what do we get? This is, for example, in 2011, in the fall, late fall, everything looks nice. Winter wheat has been sown, it's nice and green, and no winter until the 31st of January. And within one night, the temperatures dropped by 25 degrees, and they stayed down there without snow. And we had black frost for 2 weeks, and the soil was frozen 50 centimeters into the ground. And then it got unusually warm. So the plants were sitting in the frost and having thirst because it got 10 degrees above zero. They wanted to grow and they were frozen. The roots were frozen. And this is one of the biggest problems we may have in the future. And this is what it looked like then in the 1st of March, as if we had sprayed Roundup. And the whole region looked a little bit like that. And this is what it looked like 6 weeks later. And you can see here the composite crosses, a mixture of all these varieties, they recovered. But we had by chance also grown the parental varieties because we wanted to increase the seed. What you see here is one, probably monopole or Besostia, because they can't stand it. They are made for our climate, but the rest simply died. There you see the power of genetic diversity. And so that went on, 9 organic farmers, 3 millers, 13 organic bakers. I put a few papers also in the reference list. You can read up on the work on the what these populations do. So she combined millers, bakers, and farmers to do this thing on farm, to start with living labs before this was really so common. And so we used a good reference variety, organic reference variety, very good baking. And we use Brandex, which is a population from the Doddenfelder also an organic population, but not made by us, made for resistance to stinking smut. And we used Agroecology, which comes from Martin Wolf. So just to look at yield and yield stability, those are stability indices, and you have the Aristaro, the pure line, you have the 2 populations, and then you have references, is the official variety trials in the 3 states where the trials were run on the farm. So the 3 states had yields 4.8, 4.9, 4.2 tons for organics. Our equality was higher than any of these. And the Brandex also, and the lowest was the pure line on average. And that was in 21, in 22 the same. And so then you look at the variance parameters, the highest variance. The best one was for Aristaro, low variance and stably low. Yeah, that's not what you want. But you have other factors that were better in the others, but basically the yields were good. And the quality also, they like baking. So protein, yeah, this was the state average, and this is what we got. Here Aristaro was better, because it was a pure baking wheat. And but still, the farmers, the millers, and the bakers, they went on for a baking campaign with all 3 of them. And the baking quality of the populations was most reliable, although it didn't have the highest protein or highest wet gluten, but it was very reliable. It was very clear what would come out. And so baking and marketing. Marketing of an innovation, that's the key. You have to train the bakers. You have to use social media. You have to do innumerable articles in newspapers and magazines. I think we had 350 to 400,000 copies distributed through different articles and magazines. And then website and video for the baking campaign. We found it very weird. It was a designer said, what do we do with pop wheat? But it's a population, yeah. So, but while it's difficult to make the market accept something new, what about the others? So they worked with the chain, and they trained the farmers and the millers and the bakers to make videos. And they made the videos themselves without being told what to do. They were asked to address certain topics in their own way. And all actors tell their own story. We have a beautiful movie. I have the link in a sec. And so we have a movie now. Either you have the short movies by each of them separately, or you can look at the long version of 23 minutes where everything is combined. So this is the movie you find on our website. And they also did a booklet on how to do this, to explain what is a composite cross, and it's something different than a variety mixture. Really different. So, but now we go with wheat and peas. Come back to Philippe. And we checked what can you do. And so what you see, mixing always increases the protein content of the wheat. Every single wheat variety and population we tested was increased by at least 1 percentage point, and everything was raised from, if it was feed quality in the pure stand, it became baking quality in the mixture. It's robust for the different varieties. And we look at broken peas, we look at cleaning, and basically what you find is that in the end, the first step of cleaning is enough to reduce the pea part in your mixture to about 0.5% if the thresher works properly. If you thresh wheat peas together and you thresh as tough as you normally would to thresh wheat, then you have a lot of broken peas. So we have to work on peas that don't break so well. We have to work on threshers that don't break the peas, and we have to look at the overall system. So in the end, you have a little bit of peas inside. And the regulation says if you have broken peas in there, this is black, this is, we call it black trash, and that means you have a contamination. But why? So we could look at color and stability of pea seeds, use color sorters. We could work on the best settings for the combine, separation technology. And what about baking peas in the bread? Why not? We spend a lot of money paying for bread with soybean, with sunflower seed, or bread with chia seed, or all this kind of stuff to make it special bread. What about homegrown proteins in the bread? We found out that French bread, baguette, traditional baguette, always contains fava bean flour because it makes for a better crust. Oh. Yes, I was so surprised when I found out. Okay, so the traditional bakers add fava bean flour to the baguette. And so our new project is about, it has an R in there, and we call it Reallabor in German, which means living lab, and work together with the farmers and millers and bakers. And then the mill takes over, the baking campaign comes, and then we do workshops with the bakers, with the millers, and with the public, and make them taste the bread. So 1%, 3%, 5%, 7% of wheat. This is a picture out of a journal, which is wheat and soybean, but with peas, it looks exactly the same thing. You cannot see a difference. You do taste a difference when you have 7%. And the biggest difference you taste is as soon as you add peas, it tastes saltier because the recipe is identical with the same amount of salt. But actually, you could reduce the salt and have the same salt taste with less table salt, which is also positive. Aromatic smell and taste is good. Longer shelf life with 1 and 3% of peas. We say we have the same thing when you have potato bread or so. And higher nutrients, especially proteins. So go and market it instead of calling it a contamination. That's the valuation, what Felix said. And is not you grow wheat pea mixture and bake it directly. Our idea is to grow wheat pea mixtures. You run them through the normal cleaning process. You have 1 fraction of peas coming out, a fraction of wheat, and the trash. And then you remix the peas. Because sometimes in the mixture you may get more peas or less peas, because it depends on the year. But if you clean it, the first step, you have less than 0.5% peas, and then you can throw in 2 more or 3 more percent of peas, and then you have approximately what you need. But we have to adjust the breeding. We have to breed for mixtures, but also simply looking at wheat, conventional versus organic, you see what happened in the past for 30 years. No yield increase under organic conditions. Nobody has been looking for it. Did anybody breed for yield under low input? Not really. They only bred for quality, which is also good, but we need more than that. So resistance, competitive ability, and efficiency in mixed cropping are important breeding goals. So yield is a political definition. What is yield? It's the harvested goods, but are ecosystem services also part of our yield? Is it yield per hectare or yield per person? Small farms with more interactions have higher yields per hectare, but they also have higher work input. Can we afford to do everything at a huge scale and lose a lot of land because we don't care? Or as we get more and more people, we will have to be more and more intensive, but we can do ecological intensification. And what can we change? What do we feed to our animals? Yeah. And permanent grassland, or also simply 2 years of grass clover, do a lot of organic matter input to our land. And after grass clover 2 years, you can grow wheat without much input. You don't need pesticides because the soil is healthy. And you already save fertilizers and you save pesticides, and you give something decent to the animals, and you can put the animals even on the pasture. And we know if you put them on the pasture, we have a lot more birds, we have a lot more insects, we have a lot more everything. But then we don't get 9,000 liters of milk from the cow. And if you look at what is the role of what, this is from the Soil Atlas, freely available on the internet. We have, this is worldwide, this is millions of hectares of land dedicated to forest, to grassland, to tundra, to desert and semi-desert, marshland and moor, arable land. So this is the arable land in the world. And then here, the settlements. In here, this is the amount of carbon stored in these grounds. And if you look, 6.2 million, I could be square kilometers, not hectares, sorry, produce 657 million something, I have to look it up, sorry, yeah, square kilometers and gigatons, 657 gigatons of carbon in the ground. While 6 times as much grassland produces a little bit less. But the double of the arable land produce only 1/5. So we have all reason to look at the grassland and to do re-wetting of our wetlands. This is where we can put carbon into the ground. And it's a very small area compared to what we have. Yeah. And that's why my argument is put the ecology back into the fields. Of course, we need to re-wet the wet areas. And also think about permanent and semi-permanent grassland. It's extremely important. Forest is also nice, but not as strong as the wetlands. So One Health connects all levels: soil, plant, animal, human. And biodiversity helps prevent dysbiosis. And truly increasing biodiversity needs a systems approach that goes far beyond plant protection. And it also allows the reaction to the climate catastrophe. If we use these populations, they perform well in all weather. Yeah, we have Hungarian varieties running alongside, and we have typical German varieties alongside. In very hot years, the Hungarians outperform everybody. In very wet years, the German varieties do fine, but our populations always do fine. So we need to breed for mixed cropping. We need to develop technology for diversity-based production. And so agroecological approaches are long-term and systemic. And if you have excessive N inputs, they lead to more problems with harmful organisms. This is not an appropriate practice. Soil compaction, naked soil is not an appropriate practice. Soil fertility and soil health can be built via maximal use of plants, not only as field crops, but also as green manure. And this is where the organics have a problem. If they don't have enough soil fertility, they cannot be as productive in terms of producing seed to the soil as conventional ones that have more fertility. And this is, although I work for the organic sector, I'm sure the future is somewhere in between. We need to combine it, be flexible and adaptable. And our current project actually is I square C to the 5. Inter and intra-specific diversity, so diversity between crops and within crops, for complementation, capacity, compensation, cooperation, but also change. So the 4 C's we expand to the 5 because the change in our times is extremely important. Healthy soils for healthy plants, that's what the E-Forum has been saying for 50 years. It's still true. Thank you.